In the past decade, electric vehicles have evolved from being a somewhat rare yet exciting sight on the interstate to becoming a driving force in public and private transportation. But this proliferation comes with the challenges of energy consumption and safe, rapid charging. To properly manage electric vehicle infrastructure, the transit of both power and communication must be reliable and standardized enough to provide needed solutions across the various regions of the world to continue accelerating the development of clean, efficient energy to keep our society rolling smoothly. Welcome to today's Tech Chat, sponsored by Mouser Electronics, where we chat with engineering experts about the latest technical innovations that are shaping and reshaping our world. Today, I'm excited to welcome Errol Leon to our Tech Chat. Errol is the Systems and Marketing Manager for EV charging and smart meters at Texas Instruments. Welcome to today's Tech Chat, Errol.
No, thank you, David. Thanks for having me. It's great to be here.
So today we're going to be talking about some of the trends and advancements that are allowing electric vehicle charging. So can you share with us just a little bit about some of the things that we'll be expecting to look at today in our presentation?
Oh, yes, definitely, David. So one thing that we see, I think, within electric vehicles, right, is that there's a mass adoption just within the grid itself, right? And one of the things that we see is a lot of different sources. I'll take a step back here from EV charging real quick just to talk about the grid itself. We have solar. We have energy storage that's becoming very big as well within this industry. And one thing we see here is, grid capacity, right? How do you effectively take all these different sources, integrate them into the grid? And if you think about it, right, with electric vehicles, it's the same thing. You can think of a car, especially electric vehicle, as just essentially an energy storage on wheels. How do you charge that, right, with the grid capacity where it is? And effectively, how can you utilize, that as a source at some points? And I think that's where we're going to get to in the presentation today from some of the trends actually is, what we're seeing within the industry, within, vehicle to grid and the needs for like bidirectional charging. And then how can we accomplish that with communications to enable that. So that will be actually the agenda for today.
And I'm particularly interested to learn a little bit more about that communication, because I think when we think of grid, we always think of energy efficiency and the proper use of the flow of energy from the source to the load. But now with a lot of modern processing systems, which we'll be talking quite a bit about some of the most advanced ones here in a little bit, but that ability to pair communication along with the flow of power seems like it really can open up a lot of new doors and enable a lot more efficiency evaluations for making sure that the grid stays reliable for these electric vehicle changes and adaptations.
Exactly. And I think that as we're seeing these new communications come into play within these different standards, as we're seeing worldwide, one is, for example, is this ISO 15118, which is a part of the CCS standard or NACS standard, which is currently being defined, by Charin. This is where we're starting to see more enablement of data rates, right? And with those increased data rates, now you're going to have different smart features and optimization as what you just described there, David. The overview of EV charging, right, of future trends, right? One area in particular is exactly what you said here is, on the power side, right? As we're starting to see, there's more increase in power, right, being output to, some of these cars. How do you charge a car faster? And this is where we're starting to see things like from DC chargers that you'd see back then of 50 to 150 kilowatts. We're starting to see more trends of going towards 300 to 900 kilowatts, right, on DC fast chargers. And even so, we're starting to see, if you're looking at, let's say, industrial vehicles, even higher, right, than that, as far as if you're looking at semis or, buses, those are going into what they call the megawatt chargers. Now, AC chargers as well, you're starting to see that trend go up as well from your level 1 AC chargers, right, which is less than 3.7 kilowatts, or even AC chargers, right, wall boxes that were maybe 11 kilowatts going up to 22 kilowatts or so. So with that, right, there's a lot of demand for, higher power density, a lot more higher demand for these multi-level topologies to increase efficiency as well. And then bidirectional topologies. And if we look at here on the right-hand side, semiconductors that we have today within TI, right, we do have different devices that can enable this within these sort of power topologies designs here, right? And that goes from real-time controllers, where you're effectively trying to utilize it for digital power supplies, or like these power modules, gate drivers, right, that are isolated, even isolated bias supplies, and then precision signal chain that's utilized for the feedback loop to control, right, the amount of power that's being output there. So this is one aspect, exactly like you're saying, with the power side. But then the question is okay, how do you enable that from the communication side as well? And so that's where, the communication side, if you look at it for CCS or this NACS, this ISO 15118-20 is what's going to enable that. So I know we have like two different standards if we were to talk about it. There's the IEC 61851, which was like, the previous standard, still a part of the standard today because it defines different parts of the charger, both for AC and DC chargers. But they also have the communication there for PWM signals that were utilized to communicate with the car. And that's still prevalent today. But there's this new communication, right, that will enable, like I was saying, those higher data rates and data throughputs, which is ISO 15118. And there is a -2, which is out right now. And then later on in industry, they're replacing this -2 with this -20 standard, which is going to have that bidirectional capabilities here.
It looks like the portable chargers were emphasizing that bidirectional capability. However, for like the public charging stations up to 22 kilowatts, and then the much larger DC charging stations, those seem to be mostly in the unidirectional. What extra challenges does having that bidirectional present when we're dealing with kind of that private application where it's going to be people in their own homes? Why is that a particular need for those particular kind of applications?
Multiple ways for that. So one would be just some of the key features that you can have, right, with a residential, depending on the region, right? So for example, I would say even here in Dallas, right, there's some really good capabilities there where if you were to have, like, for example, vehicle to home, in the case of, let's say there's a power outage, you can utilize then your car to then power your home in those sorts of like emergencies. Another thing as well that is a big trend will be, and we kind of see this within certain standards, like for example, in the UK, I think it's called PAS 1878, which is kind of defining these smart electrical appliances. And kind of what it is it's a way where you can then have power management and optimization amongst these different power appliances. EV charging is actually designated as one of those. And so what can happen there is there could be times when maybe you utilize your car as a source when the energy rates are really high at the moment, or if there's so much demand on the grid where capacity is starting to get towards very close to capacity with the usage, then you could start utilizing, these other sources, right, to compensate for the grid. So that's one area actually where we could see a lot more enablement, right, within this bidirectional charging.
And hearing it explained that way really underscores why the bidirectional communication alongside the power is so important, because that sounds like there's so many variables that both the energy capacity of the vehicle along with the current energy production and grid capabilities need to have some central control system that can compare when the most optimal times are to be able to do that bidirectional charge sharing.
Correct. Exactly.
Thanks.
Yes, and so like going back into it, right, this is just showing some like the communication side, right, between the car and the charger and how that would go to the home, right, and essentially to the grid. But if we were to, look at it from, how can we enable this? This is where actually TI has looked into different areas here, and one of our key focus areas actually are these 4 categories within the grid. So if you were to take all these different connected areas here, most of them can be utilized within one of or a few of the four categories here of high voltage power conversion, current and voltage sensing, edge processing and connectivity, and battery management. Within, let's say, like a charger itself, right, you would probably use high voltage power conversion, current and voltage sensing, and that could be something within RCD for if you're detecting ground faults. That could be metering in the sense of detecting like how much power is being either input into the car or even vice versa, outputted from the car back into the grid. And then edge processing connectivity, that would be your wireless side or your wired side communication to the vehicle, which we'll talk more in detail on. Or even on the wireless side, if we're looking at it from maybe you want to connect it to the cloud, right? Or towards like, your smart home, maybe with like Matter, which I know is one of the new smart home protocols. So that way you can control everything through your phone or through some sort of app. That's one way also within that communication side that you can do this.
So previously, I know that there's been a lot of different devices that can do simple energy monitoring, or they really just sense the current and voltage and power consumption. And so this, based on that edge processing and connectivity and communication level, what sorts of things besides just that current and voltage sensing does that edge processing and connectivity allow you to be able to provide in that bidirectional communication?
One, I would say, would be the enablement, right? So just the communication itself. So being able to get timely updates. But most of it, I think, is just like the communication protocol itself. Now, there are other ones, like if you're looking at it from a commercial standpoint, where you have plug-in charge and it's identifying your vehicle and you don't have to get out your credit card or your phone, right, to enable payment. It automatically registers your car, and whatever is tied to that car ID automatically just bills that car. So with those sort of features, right, and in this case, residential, it wouldn't be as much of a concern, but let's say you have just your identification going through that line. This is where some of those protection schemes are also needed as well. And by that, I mean like certain encryptions, right? So that way your data is safe, because as you know, the more things become smarter, the more data there is, the more it needs to be protected.
And that's one of those ongoing challenges of any edge processing is anytime there's more data and it's more accessible for convenience. And in this case, what you just mentioned about some of the automatic vehicle ID, automatic billing, that sounds like a huge step up in convenience over traditional fueling. But yeah, that data security aspect is certainly going to be critical to a lot of people.
Oh, yes, definitely. Definitely, especially if you have your payment information, right? That's definitely something you want to keep. Definitely want to keep secure.
Absolutely.
And on that, I mean, there are different already protocols to do that and encryptions to do that, and this is where I think we can kind of go into some of the solutions here, because one of the things that we can do actually is we do have some devices that enable the most up-to-date encryptions. But before getting to that, I just want to say, with the standards, this is one of the things actually I just want to highlight, is that this is a very important area for us, especially, within renewable energies and the environment and this infrastructure and this whole, I guess you could say, energy transition is something that we really believe in, right? And it's going to be a value for society in all aspects, from cars to solar to just, a smarter grid. With that, these standards are, to define them are very important. And this is why TI is actually involved in Charin for some of these standards in some of these task force to help with trying to collaborate with other organizations and seeing how we can adopt this as soon as possible.
Do you foresee initiatives like this running into some challenges similar to my background is industrial communication protocol, where there's been so many standards that have been put forth to solve a myriad of issues with the intent of unifying into a single standard, but that has proved to be difficult over the years of replacing lots of existing standards with a single one. Do you foresee those being a bit of a challenge for initiatives like this?
I would say, yeah, like anything else, you're right. Like when you have already something defined there, like, how do you make sure that those standards that were defined in the past, that you have the interoperability aspect? And that's something actually that's being taken into account within defining some of these new standards, is how do we make sure that the adoption rate, that it's easy, but then also the older standards are also being, you're able to connect right with maybe some of the older standards. And so I think it's going to be, at first, we're going to see, probably some of these newer standards come out for these different features. And then there's going to be some backwards compatibility. And then over time, I think later on, like as things progress and as, the infrastructure matures, I'm sure that then it will start combining into more of like one standard over time. And if we see, look on the next block diagram here, if we were able to look at a charger and look at it just from the processor itself as the main focus here, if we're connecting to different parts of a charger here, which this would be more like a level 2 charger, a lot of the peripherals that are needed to connect here, they're very similar in the sense that if you have a Linux processor, in this case, then essentially the connections are going to be all the same and somewhat universal. Let's say, for example, here, if we're doing the ISO 15118, you'd have some sort of home plug GreenFi chip. You would then have some sort of MCU to do the IEC 61851. And then you would have some security accelerators to do the encryptions and a Linux core to run the different stacks that are needed from the application software. Same with OCPP, there would be some sort of application software where you can either run it through some of these medians here, either through Wi-Fi in this regards, or Ethernet, or even cellular in this case. And then if you look at the difference between different regions here, one region you can see if you're trying to do, let's say, GB/T or ChowG, which utilizes CAN versus home plug GreenFi, then you would have your CAN enablement here as well. So this is actually some of the devices are our AM62 line, which is our new Satara processor line, which has like A53 cores in there, is actually a really good device for this application because, one, you have the choice of multiple cores. You could have a single core, a dual core, or even a 4-core or a quad core for this case. And in addition to that, it has like hardware security modules in here to enable those encryptions that are needed for this space.
What sort of devices and development solutions are there available for this kind of diagram architecture that can make use of some of those different either geographical standards or just connectivity and communication options to make this easier for the developer to be able to make use of?
Good question. So over on the right-hand side here, a quick block diagram of the different portions here of like the front end and back end communications. And from what we highlighted before, we do have a good amount of solutions here actually to enable this edge processing connectivity side, both on this front end and back end side. So the main part of this, right, if you were to look at it from, I guess you could say the brains of the operation in a sense would be the AM62, like our Satara product line that enable those software stacks, HMI, and also the communication to those different peripherals that are needed here, both on the back end and front end side. Now, if we're looking at it from the back end side here, there's a few ways that you can enable OCPP, which is the Open Charge Point Protocol. We're looking at it from the industrial side here, or the commercial side, I should say. Usually, if there's multiple chargers, they'll communicate to some sort of charge point management system. And this is where there's a few ways that you can implement this. LTE is one way that you can do it. Wi-Fi is another way. And then even Ethernet, if we're looking at it from a wired sense. And then sometimes, you could also utilize it in case of, let's say, reliability. Like sometimes there's some RF challenges. The environment has harsh RF. Sub 1 is also another way that it could be implemented almost as a backup sort of solution. But if we're looking at devices that can enable that wireless side for Sub 1, actually, we have our CC 1312 device here, which is one of our Sub 1 MCUs. We have also one of our newest devices, actually, which has Wi-Fi 6 capabilities, which is our CC 3301 device, which we actually do have now M.2 cards that will actually fit into our EV charging development platform, which I'll highlight a little bit later. In addition to that, if we're looking at also not just this commercial space, but then also a residential case, I think I know I talked about Matter a little bit earlier for smart homes. This is actually a way where we can enable the Matter protocol for a residential charger, and that would be with our CC2652, our 2.4 gigahertz devices here. Now, if we're looking at it from a full solution as well, these actually, we have a board that connects a lot of these together, and then they actually connect to this analog board, which then demonstrates a full level 2 charger. And then in addition to that, we do have software stacks as well. One actually that we utilize for our demonstrations, both at trade shows as well as demonstrations from some of our videos that we have on TI.com charging a few cars, is this open source stack actually from Pionix that demonstrates the ISO 15118 communication, OCPP, as well as IEC 61851. So we do have reference solutions that could be evaluated for any customer who's looking at developing an EV charger or a new product. And the great thing about these is that it helps with not having to build from the ground up. This gives you at least an easy way to evaluate the solution and then leverage what's existing there to help get to time to market quicker.
Now, I know you've mentioned the Matter protocol a couple of times, but I kind of want to go back here and just kind of emphasize that key point that you've got there, the flexibility one, where it's talking about both grid resources and home automation. I think when we talk about EVs, really it's the burden on the grid and the grid resources that get a bulk of the conversation because it's a really big issue. But it also looks like there's been a lot of really intentional design into home automation, because even on a very small scale, that can help increase the effectiveness and the efficiency of potentially hundreds of thousands of devices at a very small level, which would certainly add up to large benefits to the grid over time. So seeing protocols like the Matter protocol being included as an option in this takes that ability of this processor to be used in lots of different situations.
Exactly. And you're right. Like, if we're looking at maybe a few devices, it doesn't look like much, but then when you add them all up, it definitely becomes a significant amount of power. Two ways to look at this. One would be the devices that we have, and then, how do we put all of these together to demonstrate that this would work, in this sort of application, in an EV charging application. And then what does that ecosystem look like to help easily implement this? So one of the features here actually is the AM62 EVSE dev platform that we have here. And what it's been designed for actually is to meet the IEC 61851, meet ISO 15118 standards, and then also have some flexibility to do the open charge point protocol, and then also show the capabilities here of HMI. Now, this is where the system gets a little bit more complex, right? And so there are different sorts of things, if you look at it from a software perspective, of lower level software and higher level software. In this case, maybe middleware is a better term for it, right? Where you have the application software. Those are pretty complex. And this is where there are some third parties that do this actually as their product within industry. For example, highlighting Pionix in this sense, they actually do have different software stacks to implement these sort of features on, a Linux processor, such as the AM62. Having that ecosystem is really good too from a support perspective, because now we're actually able to not only show just the lower level peripherals, but now we can show the enablement from how this all comes together. And this is also where we've also leveraged some of our third-party partnerships as well, not only on the software side, but also on the hardware side. As you can see here, this is actually our AM62 hardware that is in collaboration with Vitec here. So this is just one of the solutions that we have for enabling these EV charging protocols here.
And I think that's pretty common for large solutions like this, or large scale solutions, especially when we're bringing things into the digital age, to be combining multiple platforms together, where it's not all locked into a single party, but having some of those third party options with open connectivity and protocols that can adapt to other situations.
Exactly. And that's why it's important to have not only the right devices, but also the right ecosystem or support as well. And that's something that we've worked on to make sure that within this space that we do have the tools needed to be able to help make things easier to implement. A pretty good example here where I was only showing just only this upper top part here, but if you now look at it from all the different boards that are needed, in addition to that, the software that's needed, this actually enables you to evaluate it from the monitoring circuitry, the relay, the connections to the grid, RCD, weld detect, and auxiliary power supply, all the way to like the edge processing connectivity, wireless for your HMI side. Essentially, if you look at all this is all just a level 2 charger example here. If you connect all these ports together and run the appropriate software here, you can actually evaluate that proof of concept here, which then, like I said, leverages the open source software stacks. You could leverage some of the hardware here, whether that's one of our third-party kits here or even one of our EVMs. And then even on the graphics side, we actually have different third parties actually that we have partnered with and collaborated with for the different GUI graphics that capabilities that can go on this display as well.
So with so many different third-party solutions for some of these things, like GUI software, software stacks, that seems like it can sometimes take a project and almost make it a little bit more intimidating when there's so many different options available. But one of the main takeaways I see here is that the hardware solutions being modular and the ecosystem that ensures that everything works well together is what allows a lot of customization. So you're not locked into a single solution, but you know that there's going to be support in whatever kind of project you're trying to undertake, rather than having to find all of these third-party things and just hope that they all work together.
Exactly. And I think you've touched on it right there, David, which is the key takeaway is flexibility. And then on top of that, how do you make it simple to implement? Other than that, I would say from a demonstration perspective, I know I talked about the different demos here, a couple trade shows that we went to before that showcase some of our solutions here. So one actually over here on the left, as you can see, this is actually one of our first prototypes that we demonstrated back in Embedded World of last year. And then in addition to that, when we went to Electronica, we made sure to make the form factor a lot smaller. And this is actually showing those different GUIs that I was talking about, where there's flexibility here within different GUIs that you might want to do. So for example, there's a Qt here, Altia, and then this one's based off of the Everest platform. And what we've done here actually is our first implementation was to first demonstrate that we successfully do ISO 15118. The next progression in this was to say, okay, well, we've got this data, can we wirelessly send this to some sort of centralized location and be able to output this, right? And so what we ended up doing was making this into essentially a gateway that also can be an EV charger. And then each one of these chargers is communicating with a different wireless communication here back to the gateway, and then displaying that charge information for all 4 chargers. And then we do also have links to the videos to kind of showcase our solution, because all the hardware actually that's here that we've been showing is also in all of these chargers as well. But we do also have a video not only showing the demonstration here from a simulation perspective to show this, but also to show demonstrations of actually charging different vehicles.
I'm sure being able to go to a show and see the demonstration live is certainly powerful for a lot of people, but the ability to be able to show real life charging, I suppose that's probably something you can't really do inside the trade show floor. As exciting as the hands-on demo is, that's great to be able to give a link to videos so that people can actually watch what that's going to look like in the real world.
Right, exactly.
You've mentioned a couple of times that Everest software stack. Could you explain just a little bit more about that Everest software?
So yeah, Everest is pretty much a Linux open source platform, and it actually is a tool that has different software stacks on it. So you can almost look at it in a sense like Legos here, right? And maybe there's certain ways that you want to implement specific features to your charger for development. What they end up doing is they have a really nice software tool that enables quick development to testing out software here within these different protocols that you would want to choose. That's, I think, where it's been pretty nice, because if I want to test out DIN spec or the ISO-2 here, or even OCPP 1.6, I can enable that in this sort of software tool that allows me to do that. It's a little bit more flexible and customizable in that sense. The other part too is that there's still a lot more development that's being developed at the moment. So ISO 15118-20, as well as OCPP 2.0.1 are different protocols, right, that are being developed as we speak here. So there's a good amount of flexibility, and there's even tools in there for monitoring and simulations. So it's definitely a fascinating tool, and I recommend that. This is one of the tools actually that I recommend for those who are developing to definitely check out.
It's definitely, I can see that it's designed with not just residential and commercial, but also industrial applications, because I see a few things on this list, including Modbus, Node-RED connectivity, that are fairly common in the industrial connectivity world, which is a little bit more in my background area, but those are certainly very familiar to see. So it seems like it should allow this to be able to be adaptable to a lot of different situations, not just the commercial and residential.
Yes, and from the software side, I mean, that's one other area I definitely want to highlight as well, is if we're looking at it from a hardware perspective, depending on different company resources, right? Sometimes there's also the flexibility of, in some instances, maybe a SOM might be better, right? Than because you have more of a modular sort of design. In those cases, having a SOM like a third party like Vitech is really good in this sense, right? From being able to have the AM62 SOM platform in a very optimized space with DDR4 memory and all the power as well. So one of those things they said is it provides a lot of flexibility here, and also it reduces the complexity of the carrier board or attachment board that you have. Especially if you're looking at it from the number of layers that it takes to design with the processor and DDR4 memory. This is one way where it can make it a little bit easier as well from a design perspective.
So what would be kind of the steps to getting started with trying to get into that initial evaluation stage? It seems like with so many different options that you've presented, it sounds ideal for a lot of circumstances, but what sort of resources does TI provide that can give somebody a bit of a leg up when they're first getting started with a design?
A few things here. One, we have the development platform. So if you want to evaluate it at a higher level, just from a system perspective, we do have actually our product folder page here where you can actually look into it. And some of them have links to the different software and hardware, as well as an application brief overview of a getting started guide. And then in addition to that, there are layout and schematics or something like the reference designs here that we provide as well. I would say one of the key advantages is that you have access to any of the TI products data sheets. You have access to the design files and schematics as to where you can actually modify them for your needs. In addition to that, there is the open source software. And in addition to that, and not limited either, is just our support, right? There's E2E, right, on TI.com, as well as other tools that we have available to make things smoother in the design process.
Yeah, and I know that's appreciated for a lot of people to be able to reach out, because each situation is somewhat unique, even if it may have elements that are contained within virtually every project. Similarly, each set of design requirements gives people a little bit of apprehension to knowing that a solution will work exclusively for their use. So being able to reach out to the team, I'm sure, is a very valuable benefit.
Yes, and I think with that, I mean, definitely I recommend if anyone's looking into the space and has a design, we're definitely here to help. So definitely take a look at that and these different parts of content. And what I'll say is that there will definitely be more to come in the future as we see this progression, in EV charging evolving.
Well, absolutely. That's one of the best things about technology is we can study it, we can learn it, we can understand all of the latest innovations, but it's always exciting to anticipate what's going to come around the next corner and what kind of solutions are going to be available to solve tomorrow's challenges.
Exactly, exactly.
Well, thank you very much for your time. I really appreciate that you were able to come on to Tech Chats with us today and describe some of the latest TI innovations in EV charging. This has been a really insightful discussion, and I've learned a lot. So thank you very much.
No, thank you so much for having me, David. It was definitely a pleasure.
Now, before we sign off, I want to encourage everyone to check out all of the latest products from Texas Instruments by checking out Mauser Electronics, our sponsor for today's Tech Chat. And also a special thanks again to Systems and Marketing Manager Errol Leon. Please join us again next time on Tech Chats, where we chat with the leading technical experts, just like Errol from TI, who are changing our world every day.